One thing that's interesting to me is the question of what it means to train another system. And observe that cats are usually more stupid than dogs, but they are much better at training people. And as a result, they are also less trainable. And it seems they basically have evolved to train others.
As opposed to be trained, which dogs are
Yes.
evolved to be.
Yes, it's similar to a government. I sometimes joke that government is the principle to recursively bully people. And it's invented in many, many societies independently. And once government is discovered, it's going to colonize until it meets the boundary of another government with a shorter logistics chain. Right? And so up to a certain size of a system, governments tend to be singletons. I suspect the same is true for consciousness in the brain, for instance. Across brains, the protocol changes and the degree of cohesion changes, the bandwidth changes. And so it's much easier for other systems to work up to this boundary than you for yourself to spread over that boundary, because your bandwidth is no longer large enough to do that. And a similar thing is happening when 120 people are controlling the Indian subcontinent during the British East India Company, until the local systems are figuring out how this algorithm works, and that they have a shorter information chain and are pushing out the occupants. So basically, I wonder what it means to colonize an environment, to entrain yourself with it, and to build it into structure that extends you.
Yeah.
That's a nice, I think that's a nice way to think about things, yeah. More sociology applied to biology and physics.
Mm-hmm. Except normally that we distinguish two types of sociologists: those who understand social power and those who don't. And the former are called economists. And ultimately, it's an economical problem. What meditators call energy is actually compute credits that you get computed by the substrate when you're competing with other agents that want to be computed by the same substrates in your society of mind, for instance, or more generally in nature.
Interesting. Could I jump back for a second, back to just one last thing on this error correction business? So would you say then that the notion of error correction presupposes a distinction between what's an error and what isn't? In other words, like, you know, chemistry doesn't make mistakes, so chemistry just does what chemistry does. But developmental biology, which in theory people think is driven by chemistry, definitely makes mistakes, right? You have birth defects and things like that. And so the distinction, so there's a distinction there because you make errors relative to expectation of some other observer, expectation of yourself about what you were trying to do, expectation with respect to some goal state, you know, you wanted to hit, whatever. But in the way that you guys are using this term, is there any notion of error as distinct from, you know, from non-error, or is this something else?
So first of all, there are invariances that we observe. And for instance, I told you I became an animist in recent years. And that's not because I think that physicalism is wrong, but because I think that the invariance that we're looking at when we look at living things is the software that runs on a region of physics, not the mechanism itself. Right? Our current dominant perspective in Western science is that the world is mechanical, and we need to explain it in terms of mechanisms. Yet we also understand that, for instance, money is not mechanical. It's a software that is only apparent when you have a certain coarse graining that you put onto the world to interpret the world. But also important aspects of the world make no sense if you don't use money as the explanandum. Right? Because money itself is the invariant pattern that inscribes itself onto the physical reality there. In the same way, minds are an invariant pattern, or software is an invariant pattern that we care about. We don't care about the number of transistors that implement the software. We don't care about the specific neurons that implement the mind, because the mind is able to recruit other neurons if some of them fail. Right? So the invariance is actually the software pattern. And the reason why these invariances exist is because they compress reality in such a way that it becomes controllable. And according to the good regulator theorem, if you want to control something, you need to implement a model of what you control. And I suspect that's the reason why the universe is so surprisingly learnable, because all the structure that we observe is probably control structure. And that means that the universe was able to, with its means on every level, was able to discover models. And particles are probably just vortices, so there's not much to discover. And the atoms and molecules are the emergent patterns over the particle dynamics. And but for cells, it's much more complicated, because for cells, you need to have some kind of control system, and this, that is looking into the future. And here the complexity becomes so large that you need to stay in the realm of discoverable models. And that means that you need to highly compress what the agent is doing. So you describe it as a single system with a single main concern and all the other concerns of the system being subservient to it.
Reminds me of our discussion about thoughts and thinkers, Mike.
Mm-hmm. Mm-hmm.
Yeah. Yeah, I broadly agree with that. And I would say to have a usable error correcting code, you need to also have classical communication. And what counts as an error then is a discrepancy between what some system sees and what it expects to see based on its communications with some other system. So if and this is basically Shannon information theory, right? If I'm sending a message across some channel and you're receiving it, then the message is noise unless we've already shared some sort of information, like a language, for example, or a language plus some semantic box that the message is supposed to be about. And if we share enough, then all I need to do is send a bit. And for safety, I send 3 bits to give you some error correction capacity. But those 3 bits only mean anything if we've communicated before about what the question is that's being answered. And the same considerations go over into quantum codes.
When you talk about classical communication, what alternative is there to classical communication?
Well, I think the question here is, if you have a bunch of interactions, which you're defining using quantum theory or information flow or whatever you want to use, the question becomes, what do you have to assume to call some of them classical? And you're making some assumption about thermodynamic irreversibility to call something classical. That I actually said these words, not some superposition. And you actually hear some words, not some superposition. Which gets back to what you were saying at the very early on in the discussion about encountering superpositions, but imposing order on them based on regularities of some sort. The regularities are classical, right? The regularities are kind of what we mean by classical information.
Yeah, the superpositions are not very actionable. You need to focus on those aspects that are not in superposition.
Well, the very notion of action is classical, right? I did this, not that.
Yeah, exactly. So I think in order to conceptualize itself as an observer with memories and so on, the system needs to be able to maintain a classical model of itself.
Right.
And the collapse of the wave function is the point in your past beyond you fail to pretend that the universe is classical. But I suspect the correct interpretation of Copenhagen, if you want to take that one, is not that consciousness is causing the collapse, but consciousness can only exist in collapsed timelines.
Yeah, one could say an observer can only be an observer if it considers itself to be an observer,
Yes.
right? To exist for more than just an instant,
Yeah.
to have some sort of identity over time,
Yeah, right. Isn't
to
that
have a Markov blanket, whatever. Yeah.
isn't it fundamentally then what you have to do is define some time period where if during that minimal it's like a frame rate or something where during that time, if you had multiple thoughts, multiple models, multiple whatever you were doing, they sort of are in a superposition if that whole period is what you're seeing, right? If it's not infinitely thin where you have to say, was it this or was it that, if that time period of your selflet is wide enough, then there might have been multiple different things going on, and as far as you're concerned, it is a superposition because you can't cut it any further. Isn't that what we're saying, that there's a whatever goes on within that minimal time frame, those are all superpositions, but between time frames you've got to settle it was either this or that.
Mm-hmm. Yeah. Yeah. If you think about any sort of model of an observed process, right? Think of digitizing what's going on in your laptop, right? We observe the laptop at the basically nanosecond scale. We don't observe it at the femtosecond scale. So between those observations, we don't care what happens. We just think of these classical state transitions between effectively nanosecond wide slices. And within, between those boundaries that we can look with our resolution, we don't care. Some sort of quantum nonsense is going on, but we don't care about that.
We don't really care about the duration of the event. We care about how many events are taking place during a duration that we integrate over to see them as one event, right? So even if there was a transistor interaction that one would only take a femtosecond, we very much do care if it is affecting the thing that we are going to observe on the nanosecond scale or on the second scale.
Well, we can care about it theoretically. My point was just we can't care about it observationally.
Oh, I just mean that it depends on how much energy you're moving in that femtosecond. Right, so if that femtosecond is large enough to let your computer go up in smoke, you very much care.
That's true, but we can't localize it in time.
Yes.
Right.
Maybe we can't, but I mean, ultimately we probably can if we really care. So I imagine if we were to live in a universe where all the relevant events are happening in femtoseconds, which seconds between, to build computers, we probably need to figure out equipment to deal with those femtoseconds.
Yeah, I mean, if we were protons, then we'd naturally care about that time scale.
Mm-hmm. Maybe we are protons, we just forget.
So have you read Italo Calvino's book, Cosmic Comics?
Yeah, but long ago.
Long ago. It's wonderful. Yeah. He tells us the story of the evolution of the universe from every point of view, from that of a proton or something up.
Mm-hmm.
No, I haven't seen it.
It's a wonderful, very thin little book. You can read it in an hour.
Amazing.